Go to numeric. Go to numeric. Here you can find quotient and remainder. If I divide it by 2, if I divided it by 2 and check whether the quotient is equal to 0, whether the quotient is equal to 0, sorry, or the remainder is equal to 0, then go to comparison. It is the select statement. The select statement, right? Now I have to write something. For writing purpose, I need string operation. Either even or or. The indicator, it will work. True, false. If the number divided by 2, the remainder is 0. If it is true, then it is even. If it is false, then it is odd. So let's write a number. So let's write a number 35 odd, 243 will also be odd, 24, this is even. See how it works. Just highlight the execution, run it. 24 divided by 2, even, right? So this is the beauty of LabVIEW. This is about for loop. We have discussed previously that if I equal to n, then only the loop will stop. If I is not equal to n, then the loop will continue. We have given an example of for loop. Similarly, there is a conditional for loop, that is the combination of for loop as well as while loop. We are not going into that. Then there is a shift register. Shift register in LabVIEW used to access data from previous iteration of the loop and pass it to the next iteration. Suppose that in a program there are multiple number of iterations, and in that multiple number of iterations you need to, suppose 1 to 10, you need to access suppose it is value in iteration number 5 or value in iteration number 6. So in that case, shift register is important. In for loop only you can add shift register. How to add? After a for loop, right click on the border and you can check on create shift register. Create shift register. You can add multiple number of shift register because you can go to n. You can check previous data as long as possible, right? So needs a lot of practice, so you people should take interest in it and practice it. Otherwise, it is not much helpful to understand all this stuff. So suppose we have 10 numbers and we want to find the sum of those 10 numbers. So in this case, the shift register works. In this case, the shift register works. How it works? See over here. 0, plus 1 and plus. I'll show it in LabVIEW. So suppose I want to have 10 numbers. Add a shift register. Add a numeric value. Plus 1 and plus. So see over here, all the numbers are need to be added. Final outcome is 25. See over here, 0, 1. Then you need to access 1. 1 plus 1, 2, and this 3. Then you need to access the previous iteration. Like that, if your program is required to this, we need to do this in an iterative manner. That is called the shift register. Right? The final is 55. Finally is 55. Here, any doubt in shift register? Any doubt in shift register? Here you can also do multiple number of shift registers. Here you can also add multiple number of shift registers. This is done for the averaging purpose. This is done for the averaging purpose. Right? And the alternative to shift register is the feedback node. The same thing, but in a different manner. We are not going to do this. And then there is auto indexing. Right? Going into the loop and getting out of the loop. Is there auto indexing is implemented. The auto indexing, how you can do it? See over here, if this kind of thing is there, you can just click on the border of the loop, tunnel mode. Tunnel mode, there are 3 kind of options, 4 kind of options basically. You can choose any one. Last value is only one value. Indexing means all total values of a loop. Concentrating means concatenating we are not considering. Conditional is a different issue, right? So create indicator. Now run it. Yeah, see here. 1 plus 2 plus 3 up to 10, that is 1, 3, 6, 10, 15, 21, 28, 36, 45 and 55. Right? This is the beauty of LabVIEW, where you can everything see it in graphical programming language. Clear? And see over here, this is a concatenate dot. You can see this dot. This is a concatenate dot or quotient dot. And this quotient dot is due to the mixture of two kind of data types, that is a double data type and integer string data type. That's for a quotient dot. Any doubt till now? Okay. What is the next thing? While loop we have seen case structure. What is a case structure? Case structure is nothing but the if-else loop. Case structure is nothing but the if-else loop. To get this case structure, go to structure, case structure. Right? The case structure, there are two cases, either true or false. Right? This is a if-else condition. If something happens or something happens. So, like you need to find the square root. Suppose you need to find the square root of a number, but all of you know that only square root of the positive numbers can be found out. Square root of a positive number can be found out. If that number is not positive, the square root of that particular number is somehow or the other difficult or treated in a specific way. So, why the if-else loop comes over here? Now we need to check whether the number is positive or not. Positive or not means if the number is greater than 0 or not. If it is greater than 0, find the square root. If it is not greater than 0, then show an error message. That's as simple as that. If there is a number, that number is positive. Positive means greater than 0. It should not be negative, it should not be complex, it should not be any other thing. If it is positive and its square root is can be found out, then we place that, check, place that number, check whether it is greater than 0 or not, and then the if-else case. If-else case, if it is true, if the condition is true, we find the square root. If the condition is false, we give a error. We give a error or a warning or whatever it may be. it. So let's do it. So see over here, if you do Control H, contains one or more subdiagram or cases, exactly one of which executes when the structure is executed. Take a number, find whether it is greater than 0 or not, find whether the number is greater than 0 or not. If that number is greater than 0, then there are two cases, either true or false. In true case, we will find out the square root. In true case, we will find out the square root. And in false case, we have to provide it something, some number, and write an error message. Write an error message. Dialog and ये button dialog message. Negative number. So let's suppose find out the square root of 243. It's working. 15.5885. Square root of 35. That is 5.91. Right? Now find the square root of minus 98. So it's a negative number. Okay. It's a negative number. Okay. See again. Minus 98. It is showing a negative number. Everyone clear of it? Any doubt? So these are the different structures of LabVIEW. If you don't understand, please ask. I will explain again and again, but clear it. Right? The true case, it is finding out the square root, but in false case, we are giving a error message. We are giving a error message. Where to get this error message? Dialog and user interface. There are different things. Do button dialog. Do button dialog. Right? A number, you have to check whether it is greater than 0 or not. Once it is greater than 0 in true case, you are finding out the square root, and in false case, you are giving error state. I hope it's clear. This ends the structure part of your LabVIEW. This ends the structure part of your LabVIEW. You can do n number of small programs in it. You can modify the program. obviously the ring enum is there. I'm not going into the ring enum part, but ring enum tab control, all these things are there. Then there is event structure is there, right? We're not going into much in depth of LabVIEW, right? If any doubt, let me ask, or we'll end this session. This is the structure part of the LabVIEW, right? Hopefully you people understand all these things, right?